Right now, in your company's network, machines holding master passwords probably outnumber human beings by at least 10 to 1.
Oh, easily 10 to 1, sometimes way more.
Right, which is just wild. And yet, if you are like, well, most organizations, you are still trying to secure this completely sprawling automated chaos using a strategy that was, essentially invented back in the 1990s.
Yeah, the classic giant digital steel vault.
Exactly. You take all the admin credentials, all your API keys, and you just shove them in this centralized safe, and then you just wait for someone with the right combination to ask for them.
Which is a terrifying way to run modern infrastructure, honestly.
It really is.
Yeah.
So welcome to this deep dive. Today we are opening up a stack of research focused on modernizing privileged access management, or PM.
Yeah, this is a massive topic right now.
It's huge. And our mission today is to really understand this massive, pretty much irreversible architectural shift happening in cybersecurity. We're talking about the end of that vault era we just mentioned and the move toward a concept called zero standing privileges, or ZSP.
And, I mean, it is a complete pare down of how the industry has handled access for the last 20 years. Like, the vault was a foundational idea, but the basic math of modern infrastructure has just fundamentally broken it.
Yeah, and that is exactly what we need to explore here.
Yeah.
We want to figure out why that old vault model is suddenly this massive liability.
Right.
And how ZSP actually protects the absolute explosion of non-human identities and AI agents running our networks today.
Which is the real crisis, honestly.
Exactly. And most importantly for you listening, we want to talk about how to pressure test security vendors. Because looking at the research, a lot of vendors out there are basically just slapping a fresh coat of paint on a legacy vault and, calling it modern.
Oh, the smoke and mirrors in the PAM market right now are just intense. I mean, to cut through all that vendor noise, you really have to isolate the fundamental flaw in the traditional approach.
Okay, so let's break that down.
Sure. So anyone listening to this is probably intimately familiar with the classic PAM playbook, right? You store the static credential in a vault. You rotate it maybe every 30 or 90 days. You broker the session when an admin needs it, and you log the activity.
Which, I mean, that made total sense when your IT environment was basically just a bunch of physical servers sitting in a basement.
Exactly.
You had a fixed number of servers, a fixed number of static passwords, and this relatively stable team of human administrators.
Right, but the problem is that static servers and, fixed perimeters basically don't exist anymore.
Yeah, they're gone.
Today, cloud and SaaS access is almost entirely API-driven. You have workloads like containers spinning up in a Kubernetes cluster that literally execute a job and tear themselves down in 30 seconds.
Wow, yeah, 30 seconds.
Right, so the idea of holding a permanent static credential in a vault for a workload that only exists for half a minute is, well, it's architecturally absurd.
Okay, so let's unpack this a bit. The vault becomes a bottleneck, obviously, but it also seems like it becomes the ultimate bullseye.
Oh, 100%.
Like, if I am an attacker, and I know your entire security strategy relies on centralizing all the permanent master keys in one single place,
Yeah.
I don't need to hunt around your network.
No, why would you?
Right, I just go straight for the vault. Because those credentials, even if they are heavily guarded, they still physically exist at rest. They are just sitting there, mapped to an identity, just waiting to be stolen.
Yeah, and it's actually worse than just targeting the vault itself. Attackers rarely even need to crack the vault door anymore.
Wait, really? What do they do instead?
They just wait for a legitimate user to check out that credential, and then they scrape it straight from the workstation's memory, or they intercept the session token.
Oh, wow. So they just grab it while it's in transit.
Exactly, because the underlying credential is static, right? Once an attacker grabs it, they have a permanent backdoor into your environment until that next 90-day rotation cycle kicks in.
So the vault centralized the risk, but it didn't actually eliminate the credential itself.
Precisely. You just put a big fence around it.
Which brings us to the core concept of the research today. True risk reduction isn't about building a thicker vault door. It is about eliminating the credential entirely.
Yes. That's the paradigm shift.
And that is the actual definition of zero standing privileges, right? In a true ZSP state, no identity, whether it's a human admin or an automated script, holds privileged access at rest.
Right. Between sessions, the access simply does not exist. It's gone.
So how does that actually work mechanically?
The credential is minted on demand, and we should be really clear about the mechanism here, because, well, this is where vendors start getting fuzzy with their marketing.
Yeah, the buzzwords start flying.
Exactly. In a true ZSP architecture, when an engineer requests access, the system evaluates their current posture right then and there.
Like their device health or MFA.
Right, their device health, their MFA status, whether there is an approved JIRA ticket for the actual work they want to do. If everything passes, the platform uses something like Dynamic Security Token Service, or STS, to mathematically sign a cryptographic token. And that token is cryptographically hard-coded to expire in, say, 10 minutes, and it's injected directly into the session.
Okay, so it's like a digital hotel key card, but instead of just opening the front door, it's programmed to open one specific elevator, that you press one specific button on the 4th floor, and then the magnetic strip completely erases itself before you even step out of the elevator.
That is the exact mechanism. That's a great analogy. The attack surface just completely collapses because there is literally nothing for an attacker to steal once the task is done. The key just dissolves.
So if you are evaluating a vendor, that right there is your first pressure test question. You need to make them explain exactly what happens to the credential when the session ends.
Exactly. Push them on it.
If their answer isn't, it mathematically ceases to exist, you're looking at a retrofitted vault. If they are just putting a ZSP sticker on a system that still stores a static password in a database, they're just narrowing your window of exposure. They aren't removing it.
Right. And this leads us directly into one of the most misleading marketing terms in the entire cybersecurity industry right now.
Oh, I think I know where you're going with this.
Yeah. Just-in-time access, or JIT.
JIT is literally everywhere.
Yeah.
Every single glossy brochure promises just-in-time access. But let me challenge this, because just-in-time feels like a deeply overloaded phrase.
It definitely is.
Like if I have a major server outage and I run to the traditional vault, check out the root password, fix the server, and check the password back into the back, I got the access right when I needed it, just in time. Why doesn't that count?
Because the underlying architecture hasn't changed at all. Checking a static key out of a vault for a 2-hour window is what the industry calls JIT provisioning, or JIT checkout.
Okay, so it's a checkout process.
Right, but the permanent static credential still exists on the back end. True JIT, at least in the context of modern ZSP, requires ephemeral credentials. It requires that minting process we just talked about.
So the user or the workload never actually touches the underlying permanent credential. They only ever handle the temporary dissolving token.
Precisely. And this is where listeners can get highly specific in their vendor meetings. You have to ask the vendor about the time to live for their access.
Time to live. Okay, what should we be looking for there?
Well, in a modern threat model, default access times should be measured in minutes, usually 15 to 60 minutes max.
Wow, that's short.
Yeah, if a vendor's default configuration assumes access windows of 12 hours or multiple days, their architecture is completely disconnected from how fast modern infrastructure actually moves.
Well, yeah, if DevOps pipelines are spinning up and down in seconds, leaving a credential active for 12 hours is an absolute eternity.
It's a huge window for an attacker.
But wait, if these credentials only live for 15 minutes, how on earth do you manage that across the massive sprawl of a modern enterprise? A typical cloud engineer isn't just logging into one single server anymore.
No, not at all.
They are jumping from an AWS environment to a Snowflake database to an Azure Active Directory, and that's all before lunch.
Yeah, and that sprawl is exactly why the legacy vault model just shatters under modern operational pressure. You have Kubernetes clusters, multiple cloud service providers, massively complex SaaS applications like Salesforce or ServiceNow, plus whatever legacy on-prem infrastructure you still maintain.
Right, and each of those environments speaks a completely different language. They have totally different access patterns.
Exactly. And if a platform only handles your on-prem Windows servers, and maybe has like a plugin for AWS, but leaves your Kubernetes clusters and your Snowflake data warehouse out in the cold, you are basically forced to buy 3 different tools.
Which sounds like a total compliance nightmare.
Oh, it creates massive blind spots. A modern PAM platform has to consolidate all of that sprawl under a single policy engine and a single audit plane. The research emphasizes this heavily.
Yeah, they really focus on Kubernetes, right?
Right, because Kubernetes and cloud infrastructure are often the weakest links in vault-centric deployments. Vaults are static. Kubernetes is the very definition of ephemeral.
Right.
So if your PAM tool cannot natively handle infrastructure-level access, meaning the IAM roles, the service principals, the workload identities where the absolute highest blast radius privileges live, then it is fundamentally failing its core mission.
So basically, the exact same access policy needs to apply whether the user is a cloud architect tweaking a VPC in AWS or a database admin running a query in some SaaS app. Coverage at just the traditional server level alone is basically useless now.
It really is. But as complex as that multi-cloud human sprawl is, the research actually points to a much more immediate crisis.
The non-human identities.
Yes. The human admins aren't even the main problem anymore.
This is the statistic that absolutely floored me in the research.
Hmm.
Non-human identities, or NHIs. We are talking about service accounts, CI/CD pipelines, API keys, third-party integration users. These non-human identities now outnumber human identities in most enterprises by 10 to 1. And in some heavily automated environments, it's closer to 50 to 1.
The volume is just staggering.
Yeah.
And the Vault architecture was never designed to handle a machine-to-human ratio of 50 to 1.
Because machines operate way too fast.
Exactly. Machines interact with systems thousands of times a second. You cannot vault an API key and expect a CI/CD pipeline to, pause, authenticate to a vault, check out a key, run a script, and check the key back in.
Oh, that would introduce massive latency.
It would completely break your deployment pipelines.
Yeah, if you're a DevOps engineer listening to this, you're probably sweating right now just thinking about the friction that would introduce.
Oh, they hate it.
But the landscape is shifting again, and it's happening even faster than the move to cloud. We have to talk about agentic AI.
Yes. This is where the old access models go from being just inefficient to being actively dangerous.
Wow, dangerous how?
Well, we are rapidly moving past AI as just a chatbot that drafts your emails, right? We are entering the era of AI agents that take autonomous actions across your entire environment on your behalf.
Right. The research highlights protocols specifically built for this, like MCP, the Model Context Protocol.
Yeah, MCP is a game changer.
So MCP essentially standardizes how AI models connect to different data sources and tools. So let's say I ask an AI assistant to analyze a customer data set in Snowflake, update a related ticket in Jira, and push a configuration fix to a GitHub repository.
To execute that seemingly simple prompt, the AI might spawn a dozen short-lived agent identities in the background. Each agent autonomously reaches out to those different APIs to complete its fraction of the task.
Okay, so if one human user is spawning a dozen AI agents in the space of 3 seconds, the vault concept completely implodes, right?
It completely breaks down.
You cannot dynamically provision, vault, and rotate 12 static API keys in real time for a task that takes 4 seconds to run.
No, it is architecturally impossible. But the scaling problem isn't even the scariest part.
What's the scariest part?
The terrifying part is the blast radius. If your strategy for AI agents is to just give the agent a vaulted API key that lasts for a full session, you are giving an autonomous machine the exact same massive standing privileges as a human administrator.
Oh, wow. Okay, so if that AI hallucinates, or worse, if it gets manipulated by a prompt injection attack.
Which happens all the time.
Right. Let's say an attacker hides text in a document the AI is analyzing that secretly tells the AI to, delete all database tables.
Yeah.
If that AI agent is holding a session-long standing credential, it just executes the command.
Yes.
It deletes your entire database because you gave it standing access.
You've just described the nightmare scenario of agentic AI. To actually secure these agents, the control model has to evaluate policies per tool call at the millisecond level, not just per session.
Per tool call.
Right. And this is where protocols like MCP combined with zero standing privileges becomes so critical. MCP isn't just a communication channel. It allows the system to...
Okay, so this ZSP utopia sounds incredible for a purely modern cloud-native startup. But let's be real, every enterprise leader listening right now has some ancient, vendor-locked Oracle database sitting on a physical server in a basement somewhere.
Oh, everybody has a basement server.
Right, and that application literally cannot accept a dynamic STS token. It was hard-coded in, 2008 to require a static 20-character password. Are we just leaving that entire legacy blast radius exposed?
No, because that is the operational reality of enterprise IT. You cannot just pretend technical debt doesn't exist.
Yeah.
Locking a massive enterprise into a pure JIT, ephemeral-only platform that simply cannot communicate with legacy systems is a recipe for a failed deployment.
But on the flip side, keeping your entire modern cloud infrastructure tethered to a slow, vulnerable vault just because you have a few stubborn servers in the basement that's like letting the tail wag the dog.
Exactly.
So what is the actual mechanism for bridging that gap?
The mechanism is what the industry calls a coexistence layer.
A coexistence layer.
Yeah, think of it as a digital quarantine. A credible modern platform delivers true ZSP and ephemeral access for your cloud workloads, your SaaS apps, and your AI agents. But it also has the native ability to safely vault, rotate, and govern those toxic legacy credentials that haven't been modernized yet.
Okay, so it safely houses the old stuff, but it ensures no new infrastructure is infected with standing privileges.
Exactly. But the critical distinction is that it manages both the ephemeral access and the digital quarantine under one single policy and audit model.
Ah, so it's all in one place.
Right. It tags those vaulted legacy passwords as technical debt. It gives the security team a tracked, measurable path to migrate them to ZSP over time as legacy applications are retired or upgraded without holding back the rest of the business.
Which makes the actual migration process sound a lot less terrifying, honestly. Because if you try a Flag Day cutover where you shut down the old vault on Friday and turn on the new ZSP platform on Monday, you're guaranteed to break hundreds of CI/CD pipelines and just grind the company to a halt.
Oh, a Flag Day cutover is professional suicide in identity management. A vendor must be able to architect a phased migration. You really need the ability to run the human administrator workstream and the non-human service account workstream in parallel.
And what about the physical footprint of all this? The legacy vault platforms were notorious for taking, 6 to 9 months just to stand up the infrastructure.
Just to get it running, yeah.
You had to deploy primary vault servers, backup vault servers, session brokering proxies, password rotation agents on every single endpoint. I mean, it was an endless operational nightmare just to keep the PAM tool itself running.
Well, the architecture of the PAM tool itself has to reflect the modern world. It should be cloud native and SaaS delivered.
Exactly.
Lightweight, API-first architectures shift the massive operational burden of patching and maintaining servers from your internal team back to the vendor. You really shouldn't be installing heavy agents on thousands of developer laptops anymore.
Right.
The time to first value should be measured in weeks for an initial scope, not quarters.
Okay, so let's play this out. We survived the migration. We put the legacy debt in the digital quarantine. We implement true ZSP for the cloud sprawl and the AI agents. Everything is minting and dissolving perfectly.
Sounds great.
What is the actual day-to-day operational payoff for the security and compliance teams?
The biggest payoff comes in the form of removing hidden, compounding operational costs. Think about the absolute nightmare of quarterly access reviews.
Oh, attestations. Sending those massive spreadsheets around. Hey, Dave, do you still need this AWS admin role you requested 3 years ago?
Yes. And Dave just hits approve all because he doesn't want to lose access just in case he needs it someday.
It is so tedious.
It is. And it relies entirely on human guesswork, and auditors frankly hate it because it doesn't reflect actual usage. But think about this in a true ZSP model. What happens to that quarterly review?
Wait, if no identity holds any access at rest, there are no standing privileges to review.
Exactly.
The spreadsheet is empty.
The operational burden of attestation practically vanishes. There is no rotation drift to remediate because there are no static passwords to rotate.
That's amazing.
You don't have to reconcile logs from the vault with logs from the session broker and logs from the endpoint agent. In a modern architecture, every single privileged action, whether it's a human or an AI agent, produces an identical unified audit record.
Right, all in one place.
It captures the identity, the exact target, the posture at the moment of request, the scope, the duration, and the outcome.
That sounds like an auditor's absolute dream. It's not just that you have fewer credentials to manage. It's that your entire security posture becomes mathematically defensible.
Yes.
You aren't guessing who has access. You have cryptographic proof that access only existed for the exact parameters of the approved task.
Exactly. It transforms PAM from a slow, heavy security gate into a seamless enabler for the business.
So bringing all of this research together, the mandate for anyone listening is incredibly clear. Modernizing your access management isn't about buying a slicker interface for an old vault.
No, not at all.
It is a fundamental structural shift from centralized credential storage to runtime, ephemeral brokering. It is moving from a human-centric governance model to a unified engine that natively understands ephemeral cloud workloads and autonomous AI agents.
You have to view every vendor pitch through that specific lens. Do not let them map their legacy features against modern buzzwords.
Right.
Ask them about token time to live. Ask them about their mechanism for securing model context protocol. Ask them how they handle 50-to-1 machine-to-human ratios without breaking deployment pipelines.
Demand true zero standing privileges, not just a smaller checkout window for the same old static password.
And as you take those questions into your vendor evaluations, consider this broader trajectory. We spent the last chunk of time discussing how to secure AI agents and automated workflows.
Yeah.
As these agentic workflows become the default way businesses operate, the very concept of logging in, a human sitting at a keyboard, authenticating to a system that might disappear almost entirely.
Wow. Yeah, if the machines are autonomously doing the heavy lifting in the background, a user interface with a username and password field becomes completely obsolete.
So if your entire enterprise security strategy is built around a giant digital vault designed to protect a password, how is that security system going to survive in a world where the machines doing 90% of the work don't even know what a password is?
We are guarding the wrong thing entirely. The vault was built for a world that simply doesn't exist anymore. Well, thank you so much for joining us on this deep dive. Take these concepts, take these mechanical pressure test questions, and use them to challenge your vendors. Don't let them sell you a shiny new door for a fundamentally broken vault. Demand an architecture built for the reality of modern infrastructure. We will catch you on the next one.